Hey guys, Mr. Marone here. Welcome back in. We are in section 11.6, which is our last section in our surface area, and volume unit, and we're going to be focusing on spheres. So we're going to look at both volume and surface area of spheres right now. The formula for volume of a sphere is 4/3 times pi times the radius cubed. So that's our one formula we're going to have for volume, and we're going to talk about surface area in a second. So the nice part about spheres that's different than any of the other volumes is that you only have one variable to plug in. You've got radius and that's it. Makes life a lot easier to kind of cope with that. So we're going to take a look at an example and bring in surface area now. Since volume, it's just plugging in and solving. I didn't want to give you an example and let you guys use the calculator and take up video time. So we're going to look at an example of surface area. Here they've given us that the volume is 1.8 cubic meters for this ball. All right, they made this big ball of foam to hang from a stage, and they want to know, they want to cover it with metallic fabric, and they want to know what's the minimum number of square meters of fabric that they can use to cover this ball. So we're going to have to find the surface area of this ball, and the surface area is 4 times pi times the radius squared. So it's really going to be two steps to solve this problem. The first step is we're going to need to find the radius. And we're going to do that using our volume. So they've given us, we know that volume is 4/3 pi times the radius cubed. So we're going to do 1.8 equals 4/3 pi radius cubed. And then we're just going to solve from there. So the best way to do this is to multiply by the reciprocal of this fraction. We're going to multiply by 3/4 on both sides to get rid of that fraction. So I'm going to do 1.8 times 3/4, and you end up with 1.35, and that equals pi times radius cubed. I'm going to then divide both sides by pi to get rid of that pi, and 1.35 divided by pi is going to give me 0.4297, and that equals radius cubed here. I'm then going to take the cubed root of that figure. If you don't know how to do that, it is the math button and then it's the number 4 on your calculator. And when I plug that in, I end up with my radius equaling 0.75 meters here. So that's the radius of that ball, 0.75 meters. And if I'm then going to find my surface area for part 2, the surface area is 4 times pi times the radius squared. So that equals 4 times pi times 0.75 squared. And if we work our way through that math, we end up with a surface area of 7.16 square meters. So that's the minimum amount of fabric that they can use in order to find the surface area of that figure. So we're going to take a look at two more examples of how we use spheres, and one of them is finding the volume of what's called a hemisphere. So you've heard the term hemisphere before. That was something you used back in elementary school to describe the globe. We had the northern and southern hemispheres and the eastern and western hemispheres. And basically, a hemisphere is just half of a sphere. So if we took 4/3 pi r cubed and we cut it in half, you'd end up with a volume of 2/3 pi r cubed instead. So here they've given us this figure as our last example, and they said a solid is composed of a right cylinder and a hemisphere. Okay, so it's a regular cylinder and a hemisphere. And it says the density of the solid is 100 kilograms per meters cubed. What's the mass of the solid? So we're going to have to kind of work our way through this here. So finding our volume of the cylinder is going to be pi times radius squared times the height. And the volume of the hemisphere is going to be 2/3 pi times radius cubed. Well, if my diameter is 2, that means my radius is 1. So I'm going to have pi times 1 squared times our height of 3, and I'm going to have 2/3 pi times 1 cubed. So I've got 1 squared times 3 is 3 pi over here, and I've got 1 cubed times 2/3 is 2/3 pi over here. So my total, if we just kept it in terms of pi, would be 3 2/3, or 8/3 pi. If you wanted to find your decimal approximation of that, 8/3 times pi is going to give you approximately 8.38 meters cubed. So it says if the density of a solid is 100 kilograms per meter cubed, if we've got 8.38 meters cubed, we have to multiply that by 100. So if we multiply that by 100, you'd end up with your mass is 837.7 kilograms per meters cubed. Okay, so I just did 8.38 times 100. So that is really it with spheres. It's just two formulas: 4/3 pi r cubed and 4 pi r squared for the surface area, and then we have our hemisphere one. You just cut that 4/3 pi in half, 4/3 pi r cubed in half to get 2/3 pi r cubed. If you have any questions, make sure to bring them into class tomorrow, and I'll see you guys then. Have a great day, guys. Bye-bye.